Alright, how's it going everyone? Hilder Gonzalez here today. We're going to now dive deep into this functional programming and this approach of how can we now use this mathematical proof as a way to now give us a level of confidence when it comes to write our code, since we rely on all of this mathematical toolkit that we can use, so we can focus our attention in what's really important, which is the business logic. And that's the value proposition of functional programming, or at least in theory and also in practice. And I say in practice, and I look and I roll my eyes a little bit, because this is not a solo journey. This is now something that you must convince to others of what is the value proposition of why we are using this kind of particular approach when it comes to build this particular web application, especially in JavaScript. This is one of the reasons why I love JavaScript, and unlike any other programming language like C, C++, Java, and all that kind of stuff, I really love the web technology, but it's because it's opened up it is much more, how do I put it? So don't get me wrong, C, C++, of course, they have their own place, but when it comes to look at the collaborative point of view, which is something that the creator of ARPANET actually, when they create now a protocol called network control protocol, so they think that they can have control over the network, and then they suddenly realize that it's quite complex, especially if you have now a small network that needs to interconnect with another network and guarantee now the communication from this device in this network across different networks. So instead of looking at that, they now shift that perspective and say, hey, let's go to, instead of trying to control the network, let's go to now set a set of rules that allow us to guarantee that the communication is reliable, less error prone, and ultimately the communication is reliable and less error prone. That's why they have now TCP. Why I mentioned TCP in functional programming, and especially here, because the value proposition, especially, and I know that I mentioned that before, is that by now lay down the foundation of this mathematical proof, which is something that when you go out to a restaurant, you don't need to actually know the mathematical fundamental of arithmetics. So for example, is that where the add, subtraction, divisions, and multiplication comes up to that work. So you don't need to know that, you just only know that this stuff allows you to know this. So this is a practical approach of using this tool, and that's all. So hey, if you receive the bill, you are perhaps going out with a chick, and then you see the bill, and you say, oh, all right, let me actually pay full price, right? Or you may go 50-50. I'm not a 50-50 person, not at all. But for those that works, you can split that 50-50. So the idea here is that it's quite similar to the functional programming, and we are now relying is, for example, promise, which is very interesting, and we're going to dive deep into this course. But promise, actually, this abstraction or this particular tool that allows to deal is with single eventual value. All right, so this task that at some point in the future will be completed, all right, it now is based on this mathematical proof known as if I recall, that is a monoid. But in any case, so that's the value proposition of this functional programming. All right. In theory, it sounds very good. In practice, this is not a solo journey, as I mentioned before, and because this particular journey initially it can be quite frustrating, especially if you come up with the imperative programming, for example, like JavaScript, all right, C++, C, even Java, where you have to tell the machine what exactly to do. We're now with the functional programming. So perhaps initially, and this is also the reason why we're looking this particular course from bottom top, all right, instead of a top bottom approach. So where a lot of people from the functional programming teach you all of this stuff, and they assume that you already know a lot of this mathematical proof and stuff like, and kind of like that. But the thing here, the reality is that we most of the time we get into this functional programming, and then seeing some piece of code here and there, like that follow is this functional approach. But we don't know exactly what is this and how can we apply, and what are the set of rules that allow us to at least give us now high level of confidence when it comes to write our codes. But in any case, exactly. So, show me the code. You know, the TLDR is that. Show me the code. Before going into this, again, I'm gonna make a quick recap of how do we went through all of this concepts, just to actually now have a more practical approach when it comes to write our functions and understand what this paradigm is all about. And when you need to sell that out or try to convince someone else, you already know what you are doing and why you are doing. So this is the journey of this little nice graph here is showing us the journey of learning functional programming. I might be in the pit of despair, because right now I'm working for a company that they using is a lot of this functional paradigm and functional approach. Even in React, which is a framework for building user interface, we already know how to work and how to use this kind of stuff, but the reality is that we don't know why we're doing that kind of stuff. And not only for building user interface, but also for the server. That goes beyond the scope of today's video. But the thing here is that anytime we want to now use this paradigm, see what is the value on that. But in any case, here this is how you can describe this journey. All right, where initially you come from an imperative approach, your code is kind of readable, but when somebody else actually tried to look at your code, or even your future self, then he doesn't know or she doesn't know what in the F you put in there. So to at least give you now more confident and improve the readability of your code, because this part of this imperative paradigm is require you to at least have to read. There is nothing wrong to read, but when you want to fit something, when you want to add a new feature, you want to do that fast. You don't want it to stay long hours, long days, trying to figuring out how the things work. You just wanted to know that fast, blazing fast. So again, this is what the value proposition of this. When you hit here, you are in the pit of despair. But remember to keep pushing, because you might not get all of this content at one go, or even in a week or a month. It might take a little bit more or less, depending how true you want to absorb this and apply that. Pretty much when you go out to the gym, and let's say you never hear about is hip thrust, and then you want to do that, and then once you get used to that, you say, oh, you started to see the value of this, and what are the muscles that you're working, and when you combine with your nutrition, just started to connecting the dots, and that's what we're gonna do here. All right. So here we are, okay, and then once we are able to pass this, we're gonna get is tons of readability, which the idea is not only readability. In fact, the idea or the value proposition of functional programming is that the code is provable, which means is that it's gonna work the way it is. So a question comes out, which is, wouldn't be nice to actually have a code set that 80% of the stuff are things that you don't even think about, because they're actually doing what it's supposed to do, and they're gonna do that very well. So you just take care of the 20% of the code that might be the business logic, and that's what we actually care in today's video. So because of that, we went through, well, what is the course overview, functions, closures, composition, immutability, recursion, list and data structure, async, and functional programming library. So in today's video, we're gonna explore a little bit of the function, okay? Dive deep again into this simple concept of what a function is, at least from the programming perspective as a JavaScript developer, and what now a functions based on the functional programming paradigm it is, and how can we make everything that we can, and how can we try to make everything in our code that can be work as a function and not as a procedure. All right, and then we're going to look at closures, something that I'm quite familiar with, composition I do, and also the immutability as well. For example, Redux is working and is using this stuff behind the scenes, all right, as a way to now mutate the state or keep track of the state change of a variable, of a set of variables, or an object. Recursions, this is a topic that I barely know how to work with, all right, and that'll be a very good use of my time, and I think the use of your time to dive deep into this. List and data structure, this is, well, map filters and all that kind of stuff. We're gonna see now in practice. Asynchronous and FP libraries. Okay, let's get into this. Enough of me talking. Now, the point of this is to understand that, and that's why I bring a little bit of history here. That's what I bring here, a little bit of history. The evolution of software architecture, as well as the co-evolution of computing and conflict. Both of them are conducted by Grady Butch, and that's shout out to Grady Butch, because now it makes a lot of sense in terms of where the computer science might go, and where the computation as a field will eventually move towards. So the idea here is to understand that the functional programming, or the functions, is something that is not new. Is something that comes back in the 60s, where a lot of developers back then, now at least at how Grady Butch described here on this podcast, on the evolution of software architecture, is that, hey, now that we have is this way of breaking down is systems, is how can we do that? Can we do that through processes or through atoms? Initially, we start with procedures, with the way of how we decompose all of the system is with this series of steps or through algorithm, all right? And then becomes now, I just make a quick recap of this. Because now back in the 60s and with the Nature Conference, in how now the defense sectors needs to find a way to deal with the scalability problems that they're having with this computer, because now you have a mini computer, where mini computers were a thing back then. So you have now this computer that is not only capable of running several languages, in each one of those languages are good at doing one specific stuff, and also they have to deal with now is real-time communication and distributed systems. So it's important at least to get yourself familiar with this. So a lot of this problem that they have, now we have that in the language, and this is the abstractions that we can go with. So, but again, the functional programming here, so if we're starting here with the definition of functions and procedures, all right? So a procedure, unlike a function, is something that now doesn't return anything. It might alter or not the state of the entire application, and that's a procedure. And the problem with procedures is that it leads the state of the application into an uncertain state. All right? That's why we have now this test-driven development and all that kind of stuff, like GUnit or JES or VTest, as a way to now understand that, hey, if we want to make sure that this code works as expected, or at least in this isolation as a unit, we need to write this particular code to give us at least a sense of confidence that this will work as expected. However, if we write now our code in a functional way, okay, that is going to now reflect is the receive inputs and the return outputs. So this relationship here, or this function, that is not about only returning is the computation based on its inputs, is the relationship. That's one of the reasons why we actually Kyle Simpson described here, is the relationship of how now the functions is going to take respective of its inputs and it is computed output, and that will describe now the name of this function, the semantic of this function. So this is a silly example here, because anytime we are mapping or we're passing inputs to outputs, and the more input you pass, the more output you're gonna get, and then you can map that in a way that now it creates this semantics around it. So what is this stuff is gonna do anytime you pass a single input and a single output? So in any way, the function here is this semantic relationship between these inputs and the computed output. But there are some additional features that this functional programming encourage us to go as a way to now get the benefit out of this, because otherwise you're just going to water down the benefit of functional programming. So, and that is side effects. So you need to keep all of your side effects, or all the code that alter the state of the applications that are not relevant to this function, okay, outside of this. Again, we know that this is sometimes this is not the way how life works, and how even when you working with this computer actually, or you're trying to build this kind of stuff, it doesn't work that way. So the idea is to try to isolate that, and this is just a silly example of this. So avoid side effects with function calls. if possible, right? Because side effects are like any input and output, so anything that you need to wait to complete, all right, is a side effects. For example, the storage, the database storage, network calls, DOM manipulation, timestamp, randomness, okay? Because not only that is increase the CPU heat and the CPU time delay. So anything that increases CPU heat, all right, or the CPU time delay is also considered a side effect. So the thing is that let's go to now go with pure functions. And pure functions, at least based on the Kyle Simpson mention, right, is this is a function without side effects, all right? But again, in JavaScript, is not in the definition. It refers to the function call. It is also the definition, but also is more important the function call. How this function is being called when you now runs that. So here we look at a particular example of this function, which is a pure function and an impure function. And let's say now that at some point in our code, this C, which of course might seem as a side effect, but if we now define C as a const or as a var, all right, whatever you define that variable as a const, let, or var, and you know that that won't change, all right, at least in this piece of code, this actually now makes the add to function a pure function as well as add another function. Why this is important? Because with the pure function, okay, the point of this is that the more we are keep our logic or reduce the surface area in which a variable can change, the better off will be for us. In other words, that's what we have now this. So in this case, reducing the surface of the function in which now this variable can change, it is make our life much more easy, because now the code is proven, and also that these pure functions, which is another value proposition of this, is that by reducing the surface, or by reducing the reassignment surface in where these variables can change, okay, or by reducing the reassignment surface inside of your functions, we not only improve readability, but also we increase the confidence of our code, since now this code, which is the value proposition of pure function, we can test that independently regardless the state of the entire application. So we don't need to run the entire programs to know what is the state of this function. And that's also what they mention, is that, hey, anytime you get the same input, you're gonna get the same output, especially for objects, right? Especially for objects. So you say, hey, if you receive now an object here, you better verify that that object has that particular property, and that property has that kind of stuff. And that ID, that index, actually is not some random number that you're getting. So this is what function purity is all about, is to increase now the level of confidence in your code. And when you look at certain set of code, you say, hey, now this area, because we are using exclusively functional programming, it'll work as expected, period. Whereas the other area, when you need to do some side effects, it'll say, hey, well, this is when things. I have I am not that confident that the code might work as expected here, right? And that's what it's all about. All right. So function purity is so what we care about is that the function calls behave pure. All right. Is that function when we call don't perform side effects, and it's just returning a new state out of this, which is something that we're going to talk about that later. So at least to me that was quite illustrative, and I also want to now double check here the extracting impurity and containing impurity, like this.
Okay, so if a function...
So this is now extracting impurities. Extracting impurities. Okay. Extracting impurities. Let's get this.
Is not pure for any of a variety of reasons. What are our options? One option, the obvious one, is leave it impure, and that's just how it is, right? It's got to write to the database. There's no way around it. Is not pure for any of a variety of reasons.
Okay. So what happens if a function is not pure for any variety of reasons? Okay. So what are the? How can we extract?
What are our options?
So what are our options?
One option, the obvious one, is leave it impure, and that's just how it is, right? It's got to write to the database. There's no way around it. Database writes are an impurity. They are a side effect. They have to happen in our apps. There's no way to get around it.
Leaving
We can certainly be
impure.
obvious about it. We can name that function so that it is clear. Actually, we can name that procedure so that it is clear that it's going to do something like write to the database. We can even put a comment there like, Darby Dragons, side effects, beware, right? We can put it in a file called sideeffects.js. We can be obvious about our side effects, and we said earlier the reason for being obvious is so that we make it easier to maintain this code.
Leaving impure. For example, database call. The idea is to make it clear for the reader. Make it clear for the reader that it is an impure function. Okay, in their comments or their name, but that's the whole point of this.
But we do want to reduce them as much as possible. And one of the key techniques for doing that is to take a function that may have a side effect in it and ask, is there some way for me to rearrange the way this function works and extract out the impurity, leaving just a pure function in place? That does not mean to remove that impure functionality. I do not mean to take that out of the app. You have to write to the database or what. What I mean is, it doesn't have to belong right there. If I have this set of code that's doing a very important set of computations on some kind of inputs, and then it's going to write it to the database, the functional programmer says, well, that could be two separate entities. That could be a function that does all the computation, and it could be a procedure that does the single cycle. So what we're talking about is to extract the impurity.
So what we can say is this is the function.
And it could be a procedure.
This is the function that is going to do computation.
That could be a function that does all the computation.
It can be two things.
Write it to the database. The functional programmer says, well, that could be two separate entities. That could be a function that does all the computation, and it could be a procedure that does the single cycle. So what we're talking about is to extract the impurity, to bring it to the edge, to bring it to the outer shell. That is one way of making side effects more obvious. Instead of hiding it inside of the definition of this thing that looks like a function, but it's actually a procedure, we bring it to the surface, and we make it more obvious. Example, here's an add comment.
Okay, so it can be two entities. One, exactly, it can be two entities. One that does the computation, and the other that exactly. So one that does the computation, and the other that that runs the procedure and the side effect,
which is going to construct an object and put some values into it, and then it's going to append it to the DOM. It's an impure function, right? That is, line 11 is an impure function call because we create a side effect with it, which is that we modify the state of the DOM. But there's some interesting and useful stuff happening here that is separate from the side effects. Matter of fact, not only is there the side effect of adding to the DOM, but you might not have spotted the side effect line 3 generating a unique ID. That's also a side effect. So is it possible for me to extract out the impurity and make that be at the edge, make it be on the shell, and not be obvious? Sure it is. How about if we change this code to look like that? We now have an, no, that's also a side effect. So is it possible for me to extract out the impurity and make that be at the edge, make it be on the shell, and not be obvious? Sure it is. How about if we change this code to look like that? At the edge, make it be unique ID. Matter of fact, not only is there the side effect of adding to the DOM, but you might not have spotted the side effect line 3 generating a unique ID. That's also a side effect. So is it possible for me to extract out the impurity and make that be at the edge, make it be on the shell, and not be obvious? Sure it is. How about if we change this code and make that be at the edge?
Oh, and by the time I need that computation, okay. And by the time I need that computation,
make it be on the shell and not be obvious. Sure it is. How about if we change this code to look like that?
and this is build common element. Return build common element. Exactly. This is the computation. This is when the computation happened, and this is now when our side effects is gonna run.
We now have a not procedure called add comment, but a function called new comment, whose only job is to make a new comment object. But you'll notice now that it receives the comment ID as an input. We take comment ID, the unique ID generation, and we pass it in as an argument. And then instead of mutating the DOM inside of new comment, we return back the DOM element. We return back the thing that is the DOM element, and elsewhere we do the append. Now that doesn't get rid of the side effect. It just extracts it to leave pure function wherever possible. That's what a functional programmer means by making pure functions and then having side effects on the outer shell. Wherever possible, look for an opportunity to extract out the impurity, leaving a pure function. That will not always be practical. It will not always be practical to do that, but wherever possible, this is better than leaving something as an impurity. If you can't extract the impurity, another way of getting around the problem of function impurity, the pollution that it has, the polluting effect that it has in the rest of the code, another way to do that is to contain it. What do I mean by contain?
If you can do that,
so let me make sure we're real clear. It is not that we don't make impurity happen. Like impurity may have to happen. But if there's some way for us to structure things so that the impurity does not affect other parts of the application. If there's some way for us
sometimes
to reduce the surface area of the impurity, we've had a net overall benefit to our application.
Sometimes this does not
if the side effect can pollute the global scope, that's bad, right? But what if the side effect that has to happen only ever has to affect 5 lines of code? That's a lot better than affecting the entire global scope. So sometimes we can't get rid of the impurity, but sometimes we can simply contain it. We can reduce the surface area. One way of doing that. Here I have a sum API. It's got a method on it called isBelowThreshold and a value on it. What's important here is that I call that method. I'm going to modify the numbers array, but I'm calling line 11 sum API.isBelowThreshold. I'm using that. So sum API is provided to me by like a framework or a library, and it has a function on it that I want to use. Well, one thing that I can do, if I don't want to modify the global numbers array, and I don't want to use this sum API.isBelowThreshold, if I don't want to use those side effects, one way of doing this is to wrap that entire function so that the side effects that occur are not in the global scope, but they are inside the function scope. Let's do that. Let's wrap the insert sorted descending. That was the function that previously existed in the global scope. We wrapped it in another. Do that. These two. Right? And I don't want to use this sum API.isBelowThreshold. If I don't want to use those side effects, provided to me by I'm going to. It's got a method on it called isBelowThreshold and some value on it. What's important here is that I call that method. I'm going to modify the numbers array, but I'm calling line 11 sum API.isBelowThreshold. I'm using that. So sum API is provided to me by like a framework or a library, and it has a function on it that I want to use. Well, one thing that I can do,
since I am here right now, is modifying is this, and numbers is something that is outside of this, is to contain it.
If I don't want to modify the global numbers array, and
if I don't want to modify the global numbers array, one way to contain that is to have now a function that actually is recreate the new state.
Sum API.isBelowThreshold. If I don't want to use those side effects, one way of doing this is to wrap that entire function so that the side effects that occur are not in the global scope, but they are inside the function scope. Let's do that. Let's wrap the insert sorted descending. That was the function that previously existed in the global scope. We wrapped it in another function called getSorted. And notice that there is still, line 7, a global variable called numbers. There is an array, but notice now there is also an array, line 10, inside of getSorted numbers. There's an array there that when insert sorted descending is called and line 20 tries to modify it, it is now modifying the array from line 10, not the array from line 7. And what we did on line 24 and line 25 and 26 and 27 and 28 is we passed in the one from the global scope. And then line 10, we made a copy of it. So as to not modify the global numbers array, only modify the local numbers array. Did you see how I contained the impurity? There is an impurity happening. I am modifying that array. And I'm modifying it by reference, and it's a variable outside of myself. That's a side effect. But I have contained that side effect to lines 9 through 22 instead of the global scope of the entire code. That's one way of dealing with impurity, is to contain it. In this case, wrapping a function. Now, I'll be honest with you, that doesn't often occur. A handful of times have I ever been able to take advantage of wrapping a function around another function. But sometimes that is useful. So it's a good technique to be aware of. But there is still another problem. There is still an impurity. And the impurity is that we are using the sum API.threshold and sum API.isBelowThreshold. Notice line 15, we are setting the variable. Line 15, we are setting threshold, which is modifying something that we don't know.
to encapsulate, to isolate, or to contain, to encapsulate or to contain the side effect effects of your inside of your function rather than in the global scope.
We're modifying threshold and then calling this function. That's having a side effect. And it really wouldn't work for us to wrap the sum API up into our function, because that's a third-party provided thing. It's probably actually in a separate file. So wrapping it isn't going to work. Is there any way for us to contain the impurity when we can't just wrap a function around it? There's another technique. It's uglier than this, it's worse than this, but it's better than nothing. The next technique that we'll look at, instead of wrapping a function around it, is create alongside of it an adapter function. So notice we're back now, line 9, we have an insert sorted description. That function is just out in the global scope like it was before. So is the sum API. But notice line 18, we have our get sorted nums alongside it instead of wrapped around it. And notice what's before. So is the sum API. But notice line 18, we have our get sorted nums alongside it instead of wrapped around it. And notice what's important here is that I first make a copy of the current state that is going to be modified. I take some local variables called orig numbers and orig threshold. I get copies of those current values. And then, line 20, step 2, is I set up the environment to be what I want it to be, which is that numbers is a copy of this array. Okay? It's a copy of the past array. And then I call the insert sorted descending. That's our thing that does all our side effects that we don't like. It's going to make changes to that global variable numbers and that sum API.threshold. Both of those are going to be changed. They're going to be modified as side effects. And then on line 22, step 4, we capture that changed state. In this case, it's only the numbers array that we care about. We capture the new changed state. We save that. And the most critical piece of all, line 5, we return all of the state that was modified back to its original value. Finally, line 24, step 6, we return that new state. This is very brute force. It is very ugly and would get very unmanageable very quickly if we had a more complex set of state, like, for example, the DOM. Capturing the current
and here you're talking about is a state.
And then resetting it is hard. Possible, but quite difficult. Capturing the... And finally, line 24, step 6, we return that new state. This is very brute force. It is very ugly and would get very unmanageable very quickly if we had a more complex set of state, like, for example, the DOM. Capturing the current state of the DOM, modifying it, and then resetting it is hard. Possible, but quite difficult. Capturing the current state of your database, modifying it and resetting it, really hard. Possible, but probably not worth it. But in this particular case, we had just a couple of variables that were getting changed in a way we didn't like. And so we said, we could capture those values and then restore them. From the beginning of the get sorted nums call on line 27 to the end of that function call, from the beginning to the end, during that call, everything's all messed up. But by the end, it's all back to the way it was before. So we have contained the observability of that side effect to the function call. Even though get sorted nums is not actually a pure function from this technical definition, we have achieved the more important outcome, I argue, which is that line 27 runs as a pure function call. It satisfies all the conditions that we want out of a pure function call, which is that it takes direct inputs, it gives us a direct output, and it doesn't change anything else about the state of the program afterwards, and it didn't rely upon anything about the state of the program before. Those are all the things on our checkmark list that we want, and line 27 fulfills it, and so does 28, 29, 30, and 31.
Exactly.
So this is another way of dealing with side effects, is to contain their effects. In this case, contain them to a single function. Sometimes they're going to happen. We want to reduce the surface area where side effects happen. at all costs. And if none of these things work, if you can't write it pure from the beginning, if you can't refactor it to be pure, because now you know that's important, if you can't extract the impurity so that it leaves a pure function, if you can't make a wrapper function around it, and you can't make an adapter function, if you tried all 5 of those things and none of that worked, you're stuck with a side effect. At least make it obvious.
Make it obvious, exactly.
Contain it somewhere, make it obvious, so that if there are bugs, then the future reader, the maintainer of your code, knows where to go. How do we feel about side effects? Give me a thumbs up, thumbs down. How are we feeling so far about this idea of side effects and using pure functions? Yes?
I've heard before that also mutating the state of parameters is also considered to be impure. What are your thoughts on that?
Okay, so the question is, if I have a parameter that's passed in and I mutate the state of it, unfortunately we need to be more specific around that wording. So let's look, for example, at the insert sorted description, insert sorted descending function. I want this defined in my mind. If
Insert
I
sorted
passed in
descending.
numbers rather than referring to the global, but I still called numbers.splice on line 15. Or if we consider the previous slide where I was doing it on the array numbers. In both of those cases, I would be modifying the value by reference. So I'm not actually changing the parameter. I didn't reassign a parameter to a different value. I used a reference to mutate a value at a distance. Using a reference to mutate a value at a distance is absolutely a side effect. That's the whole reason we wanted to avoid the numbers.splice here, because that is definitely a side effect. But taking a parameter that, say, was passed in as the value 4 or even an array, and reassigning it to point to a different value, that doesn't have any effect on the outside world.
Exactly.
So when you mutate a parameter, you have to ask, are you mutating the value the parameter references? Or are you mutating what assignment?
What assignment? What
The former of those is a bad side effect. The latter of those is totally fine.
Exactly. You're mutating is the reference or
Let's
the...
that topic of containing function impurity. We talked about 2 different techniques. So we have a 2-part exercise on impurity. First part of this exercise, it's laid out here in the README, and I encourage you definitely do read this, but essentially you're going to be taking some functions and moving them around or refactoring them so that the first technique that you're going to use is that technique we talked about of wrapping a function around. Wrapping a pure function around and taking some functions and moving them around or refactoring them so that the first technique that you're going to use is that technique we talked about of wrapping a function around. Wrapping a pure function around an impure function. So if you notice in our exercise, EXJS, you'll notice we have these functions, sort students by name and sort students by ID. And you'll notice that these functions modify a variable outside of
this scope.
There's our side effect. The fact that students.sort is being called, that modifies the array in place. And that's the side effect that we want to avoid. So our first task, part 1, is to take this function and to refactor the code around this function so that it is behaving in a pure way from the outside. The way you're going to do that actually is to define a function called getStudentsByName. So this is the function that you're going to modify, and in this case, most likely move to wrap around the sort students by name. And you'll notice in the README it'll explain it needs to receive input, and it's going to return the modified output, but it will contain that impurity to itself, so it will not actually end up changing the results of this particular student's file. You'll notice at the bottom of your exercise file there's a variety of console statements, and these console statements have comparisons in them. When your tests pass, essentially, each of these sections of console log statements will print true. So you want to be you want to see that get students by name when you pass in students. It should produce a return result that prints true for all of these. That's part 1.
Print true for all of
Also,
us.
make sure that you don't break the current values that happen, or these should all print true as well. So student test 1 and student test 3 should all print trues. These won't print true until part 2. Okay? So that is part 1. Make sure you check the README for some hints, some specific things that you want to do. You want to avoid the current values that happen, or these should all print true as well. So student test 1 and student test 3 should all print trues. These won't print true until part 2. Okay? So that is part 1. Make sure you check the README for some hints, some specific things that you want to do. You want to avoid actually changing these functions. So don't change sort students by name. Simply wrap something around them. That's how you want to avoid this item. For part 2 of the exercise, these functions. Part 2. Okay? So that is part 1. Make sure you check the README for some hints, some specific things that you want to do. You want to avoid actually changing these functions. So don't change sort students by name, simply wrap something around it. That's how you want to avoid the side effects. For part 2 of the exercise, we want to do something similar. We want to contain the impurity inside of the sort students by ID. We want to contain that impurity. But we're going to practice the second technique we talked about, which wasn't wrapping a function around it, but rather creating an adapter function alongside it. So remember, we have this get students by ID. That's going to be our adapter function. We want to have it sitting alongside the sort students by ID. And remember, it's in the slides, and you can check that. Remember the 6 steps that you basically need to accomplish. You need to save the current state, set up the appropriate initial state, call the side effect, capture the new state, restore the old state, and then return the captured state. So make sure you handle all of those steps in your adapter function. And at this point, once you've solved that, all 15 of these tests should print true.
Okay.
Okay?
All right. Okay. Okay, bro. All right. That'll be all for this video. Take care. Bye bye.